Good evening, Lama. Right, let's start the session. Ready, batang mo. Right, today we are going to discuss about the MCQs, right? Appearing in your tute. Right, there are a few MCQs. Starting with the page number 2. Page number 2 එල්ලන MCQ set එකක් තියෙනවා. අපි ඒ ටික තමයි කතා කරන්න යන්නේ මුලින්ම. හරි. Okay. So let's start the session then, right? So we are hoping to discuss 10 to 15 questions there, right? Okay, now this is starting from page 28 of your tute workbook, right? Right. So few MCQs are there. Lamai, to solve these MCQs, we are going to use the Sherlock Holmes method, right? You know about the Sherlock Holmes method, right? Sherlock Holmes method is which is referred to as the elimination technique, right? But it says if you have to eliminate the impossible, whatever remains should be the truth, how improbable it could be, right? That is the Sherlock Holmes method, right? Which is known as the elimination technique, right? So we are going to use that thing to solve these MCQs, the elimination technique, right? If you have to eliminate the impossible, whatever remains should be the truth, how improbable it could be, right? Okay, let's use that to come up with the good answers for these MCQs, right? Okay, we'll start with the MCQ number 1. Right? So remember that I'm writing that thing again. If you are to eliminate the, this is very important, huh? To eliminate the impossible, whatever remains should be the truth. How improbable it could be. This is known as Sherlock Holmes method, right? So we are going to use this thing, right? Okay, let's start with the stuff, right? Okay. First question. See, what are the choices appearing? CUBR, right? Second one CUI. Third choice AGI. Fourth one PbCO3. Fifth choice Ag2 carbonate. Okay, let's see what they are saying. Inorganic compound Y gives a dark colored gas when boiled with concentrated HNO3. Inorganic compound Y gives a dark colored gas when boiling with conc HNO3. Right? With a concentrated acid, a dark colored gas is released. See which guys are able to do so and which are not. And let's eliminate the ones which are not going to give you dark colored gas. So first we are going to eliminate these two guys, right? So with conc HNO3, the gas is CO2. This one as well, with conc HNO3, the gas is CO2. These are colorless gases. We know there are 5 anions which will release gases with dilyl acids. those will release the same gas with the conc acid as well. Out of those 5, only NO2 minus will gives you the NO2 gas, the dark colored gas, some kind of colorful gas. So others won't. So carbonates won't. And when it comes to conc acids, with conc acids, the NO3 minus, Br minus, and the I minus, those will give you some dark colored gases. So those are also applicable here. That is the theory part we are discussing here with this question, right? So these are not giving you dark colored gases. So these are out. These are out. Right? We are eliminating the impossible. Then whatever remains is going to be the truth, right? Okay, the answer. Second statement. Let's go through the statements one by one, Lavan. First, read the first statement and eliminate the impossibles. Then go through the second statement and eliminate the impossibles out of the remaining. Like that. So when you are reading two or three statements, you will come up with the answer. There will be something remaining, only one thing remaining. That will be the answer, right? Second statement. When the solution formed above was treated with barium chloride, a white colored PPT was formed, right? So these things, right, with conc HNO3, right? What will happen? Right? This will form the copper nitrate. That is the solution. That is the solution. Basically, Br2 gas will liberate. Br2 gas and the copper nitrate, right? Br2 is the gas release with copper nitrate, the solution. The salt and gas will liberate. Basically, H2O will also release to balance the redox reaction. With this one, I2 with that copper nitrate, and with this one, I2 gas will release with silanitrate. And as the second test, what they are doing to these solutions, which resulted after the addition of conc HNO3, they are providing the barium chloride. They are providing the barium chloride, right? So they are adding the barium chloride to this. Barium chloride. So with barium chloride, this will form the like copper chloride and barium nitrate. It is not going to be a precipitate. Copper chloride is not a precipitate. Barium nitrate is not a precipitate. Nitrates never get precipitated. Right? Copper chlorides, no. Only 3 cations are able to precipitate chlorides properly. Ag plus, Pb2 plus, and Hg2 plus. Right? So cations which precipitate chlorides, who are those? Ag plus, Pb2 plus, and the Hg2 plus. And you can think of copper plus as well. That is normally not appearing in the solutions, right? Very rare. And these things will come up with the AgCl, PbCl2, and Hg2Cl2, and CuCl, right? But here you have the copper 2 plus, right? You have the copper 2 plus. Copper 2 plus won't come up with the precipitate. This is again copper, right? So what are the things? CuB or CuI, right? Yeah, both won't come up with kind of precipitate. But this, so these are out. Not giving you a precipitate. with Cu with BaCl2. So your answer is remaining. Your answer is remaining. So if you are eliminating the impossible, you will come up with the answer. So this is your answer. So that will produce silver chloride and barium nitrate. So silver chloride is kind of a precipitate, white PPT. Right? All of these are white. Huh? All of these are white PPT. Right now? So these are the background. This is the background of this question, right? So your answer is answer number 3, AGI for the question number 1, right? So do the working if you need it, right? Right now. So your answer is answer number 3, AGI, right? Let's move to the second question, right? Come to the second question again. And before start writing, just take a screen capture. Just take a screen capture and just start writing. So then you can complete the notes even after the session, right? Without going through the video again, you can complete the notes even after session if you are taking a screen capture before start writing, right? Okay, so let's move to the second question. Question number 2. Right. So let's first copy the choices there. Barium, Br bromide, lead carbonate. Third one is cobalt carbonate, lead bromide. Fifth one, nickel sulfur. Let's see. First statement. Inorganic compound Y gives a colorless gas when treated with conc HNO3. See, with conc HNO3, no gas liberation. To liberate a gas with the Br minus, you need, with conc HNO3, you release a gas, the Br2, but it's not colorless. It is not colorless, right? It's red brown. Conc no, no the dill no. With dill, no gas liberation with the Br minus, but with the conc, you will get the Br2 gas. With this one, even with the dill acids, carbonate still releases CO2 gas. So with the conc acid as well, releases the same gas, right? the CO2 gas. It is colorless. So we are looking for colorless gases. So this is out. Looking for colorless gases. This is out. So cobalt carbonate with concatenary will release a CO2 gas. Colorless. PbBr2 with conc H2O3 you release the Br2 gas, which is red brown. So that is out. We are looking for some kind of colorless gas liberation. So nickel sulfide with conc H2O3 releases the H2S gas, which is also colorless. Right? So with conc acid, these guys are not releasing colorless gases, so those are out. So out of 2, 3, or 5, you have to come up with the answer. Yeah, eliminating the impossible, right? Let's come up with the second statement. The solution formed above gave a white PPT when treated with dill H2SO4. So what is the solution? So we are not going to think of these. Out of the remaining, let's consider the solution. Solution is coming up with the gas liberation from the anion and the H plus. Solution comes up from cation and the NO3 minus. Right? That is how the solution is formed. Gas will liberate combining these two. H2CO3 will release CO2. Solution will be given by the cation and the anion, the remaining, right? Lead nitrate here. These are solutions. For this one, it is the cobalt nitrate. For this one, it is the nickel nitrate. Right? To this, what they are doing? The solution formed above gave a white PPT when treated with dill H2SO4. So you are coming up with dill H2SO4 to do history. So precipitation. So nitrates never get precipitated. So the metal sulfate should be the precipitate discussed in there. These two guys. Nitrates never get precipitated. The sulfates are with some capability of precipitating. So lead sulfate, yes, it's a precipitate. Lead sulfate is a precipitate. So what are the precipitating sulfates? What are the precipitating sulfates? So basically only 3 cations are possible capable of precipitating sulfates. Only 3 cations precipitate sulfates. What are those? What are those? Strontium 2 plus, barium 2 plus from this block, and lead 2 plus. Only these 3 are capable of precipitating sulfates. Strontium sulfate, barium sulfate, and lead sulfate. White PPT is all the guys. This is the theoretical background with the precipitation, right? So we have to leave this one, right? The copper sulfate is not a precipitate. Copper sulfate is not a precipitate. So it's a solution. No PPT. And nickel sulfate is not a precipitate. Only these 3 cations are capable of precipitating sulfates. Nickel sulfate is not a precipitate. So no PPT. No PPT means these are out. These are out. They are saying a white PPT is given. White PPT is given. So your answer is this. So your answer is answer number 2. Lead carbonate. See how to approach to the answer. Right now? So just do the working. So we are eliminating the impossibles statement by statement. Then whatever remains should be the answer. That is our approach here, right? The elimination technique. Right? Let's move to the third question. I hope you had done these questions, tried even, right? So let's move to the third one. Right, question number 3. Let's just write the choices there. Right, strontium nitrate, magnesium sulfate, strontium sulfide, strontium nitrate, magnesium sulfate. No? The fourth one, barium nitrate, barium nitrite. Next one, ammonium bisulfite. Right. See what we can do with these things, right? Let's go to the first statement here. Inorganic salt P gave a colorless gas and a colorless solution when treated with DIL-HCl. Yes, with DIL-HCl. DIL-HCl, what will happen? No gas liberation. With DIL-HCl, only 5 anions are capable of gas liberation. Carbonate or bicarbonate, we can say, right? S2 minus, SO32 minus, S2O32 minus, and the NO2 minus. Those are the 5 anions which are capable of releasing gases with DIL acids. So no gas release, right? So it is out. It's out. They are saying gas is released. So with this one, DIL-HCl, right? So thiosulfate will release the SO2 gas with colloidal sulfur. With colloidal sulfur, right? We have to leave that thing. Strontium sulfide will release the H2S gas, colorless gases. And this one. So the strontium chloride is not going to be a precipitate, right? Strontium chloride is not going to be a precipitate. Just a colorless gas with a colorless solution, right? So we can reject that thing as well, no? Inorganic salt P gave a colorless gas and a colorless solution. We can leave that thing, colorless solution. But this one can, we have to get rid of this thing, right? Colloidal solution, right? It is not a colorless solution. It's a colloidal solution. We have to create that thing, eliminate that thing, right? Colloidal solution. So we can say milky solution. Okay. So with this one, so urine is a colored gas. NO2 is kind of a colored gas. Red brown gas. So it is not a colorless gas. So we have to reject that thing as well. With this one, right? So del HCl. So when providing H pluses to HS minus, when providing H pluses to H plus minus, it is like the S2 minus reacting with H plus. H2 minus reacting with H plus giving you the H2S gas. Like that, HS minus also gives you the H2S gas level. Right? It is like carbonate as well as bicarbonate produces the CO2 gas, no? Like that, S2 minus as well as HS minus. Both are same, both are same. Will let with del H plus release the H2S gas. Same logic, Just providing 2 H pluses will give you the CO2 here by forming the H2CO3. Just 1 H plus will be enough to produce the same H2CO3 to release the CO2. By adding 2 H pluses, this will release the H2S. Just 1 H plus will be enough to produce the H2S from the HS minus or HS minus. Right? Okay. So this is kind of a colorless gas, and ammonium chloride is a colorless solution. So we have to leave that thing. So out of these two, one is going to be the answer. Let's go to the second statement. The gas produced above converted an acidic dichromate, so acidic chromate solution to green. So these are the two gases. Both are same gas, right? This acidic came acid dichromate. Both the same H2S will convert that into green colored Cl3 plus, right? So nothing to worry there, right? The gas produced above converted an acidic chromate solution to green, and the solution produced above gave a precipitate with del H2SO4. This thing, the solution formed above, they are saying gives some precipitate with del H2SO4. Let's first copy the solution here. What is the solution available here? Here the solution is these two guys producing the H2S gas. The solution is going to be the strontium chloride. Solution is strontium chloride here. Here the solution is ammonium chloride. These two are producing the H2S gas, the ammonia and the Cl minus. Ammonium chloride is the solution here. With del H2SO4, what is happening? H pluses are not involving in precipitation. So sulfates are the ones to think of. So these two. So these two. Right? Here you form the strontium sulfate. It is going to be a precipitate. Strontium sulfate is going to be a precipitate. White PBD. Like in earlier case, only 3 cations are capable of forming sulfate precipitates. Right? only 3 cations form sulfate precipitates. Strontium 2 plus, barium 2 plus, and the lead 2 plus. Produces strontium sulfate, barium sulfate, and lead sulfate. White PPTs. Right? So this is going to be the answer, and this one should be rejected. So ammonium sulfate is a solution. Ammonium ions never get precipitated. Right? It's a solution. No PPT. Right? So your answer is going to be the strontium sulfate, as this is rejected. Right? So answer is strontium sulfate. Right? These are some theories used in this question. Right? So our answer is going to be, I put the answer here. Answer is answer number 3. Right now? So just complete the stuff. Right now? Okay. Right. I'll discuss about this gas release method again, because more of the questions are involving that knowledge. The gases, the anions which release gases with acids, that theory note is very important. Right? Right. I'll discuss that thing. Is that much important, Laman? Again and again, I'm discussing that topic, right? Because that is that much important, right? So anions which release gases with acids. Right? First concern with dill acids. With dill acids. The carbonate, or one can say bicarbonate. Then the sulfide, we can take the bisulfide as well, right? Okay. Then SO32 minus, S2O32 minus, and the NO2 minus. With dill H plus, this one will produce the H2CO3. H plus connects with these things to produce H2CO3, and it will release the CO2 gas and H2O. H2CO3 will be decomposed to CO2 and H2O. CO2 gas, colorless gas will be released. With these ones, H2S gas will release. With these, H2SO3 will produce, that will release the SO2 gas, SO2 and H2O. With this one, H2O32 minus, that is that will give you the SO2 gas and the colloidal sulfur. This is referred to as a colloidal, unclear, or turbid, or milky solution. All the terms can be used. These are giving you clear solutions. This will give you with some colorless gas liberation. These three guys are giving you clear solutions. This guy provides you a colloidal solution. And with NO2 minus, you will get the NO2 gas, which is the only red-brown gas, only colored gas. Right? This is the situation with the nil acids, and with concentrated acids, conc HNO3 or with conc H2SO4. All these ones will produce the same gas. All above ions will release the same gas with conc acid 2. And we have special tree ions which will produce gases only with conc acids. The below 3 ions produce gases only with conc acids. What are 3 ions? NO3 minus will produce the NO2 gas, red brown, right? Conc H2SO with right? Br minus with conc HNO3O, conc H2SO4 will produce the Br2 gas. Both of these guys are red brown. And the other one is the I minus. I minus with conc H2SO4 or conc HNO3 will produce the I2 gas. V is purple. Right? These are the theories we use again and again in these questions, right? Just copy the stuff if you need, right? You have these things with your notes, right? In your analytical chemistry note, this is the note number 7. This is actually note number, note number 7. Note 7 of Analytical Institute. Right. Hi. Right. Question number 4. See what they are saying. First of all, let's go to the choices there. Choice number 1 was copper chromate. Then choice number 2, lead chromate. 3, barium manganate. Then barium chromate. Then barium iodide. Yes, these are the choices. See what they are saying. The inorganic salt X won't dissolve in water. Won't dissolve in water. See, with water, they're not dissolving. Now my barium chromate won't dissolve in water, but what are the chromates won't dissolve in water? Now my the precipitation patterns. Let's discuss a bit about those things. So now my every manganate, each and every manganate will dissolve in water, right? So that it is out. It is out. All the manganetes, dichromates, permanganate dichromates dissolve in water. The KMnO4 and the dichromate stuff, right? We are using in titrations, right? Yes, we have a question. No, no. Right. So the theory background here. So I'll come up with here, right? Precipitation patterns, right? All MnO4 minus and dichromates, salts are solutions. No PPT, no precipitation, right? And when it comes to chromates, what are the chromate precipitates available? What are the chromate precipitates available? Only 4 cations are capable of precipitating chromates in our syllabus. 4 cations. What are those? What are those? Right? The 3 cations which will precipitate the sulfates and the silver right? So strontium, barium, lead, those are the 3 cations precipitate the sulfates and silver as well. These are the only 4 precipitates available in our syllabus as chromate precipitates. Strontium sulfate, chromate, barium chromate, lead chromate. And if this one is special, it is silver chromate. These 3 are yellowish. Normally chromates are yellowish. And this one is special. This one is red. Right? Those are the chromate precipitates. So with that knowledge, we can say this is not going to be a precipitate. This is not going to be a precipitate. So they are saying inorganic salt X won't dissolve in water. Won't dissolve in water. That means it precipitates, right? So copper chromate is not a precipitate. That is not available there. Lead chromate is there. Barium chromate is there. We have to leave them. But barium iodide won't dissolve. What about iodides? Halides. X minus precipitation. Right? Only 4 cations are capable of precipitating X minus. What are those? Ag plus, Pb2 plus, Hg plus, and the Cu plus. X means the halides, fluoride, bromide, iodide. AgX, PbX2 HgX CuX, right? Only 4. So barium iodide is not going to be a precipitate. That is not appearing here, right? So that is out. So out of these two, we have to come up with the answer. Eliminating is impossible. Then whatever remains should be the truth. Okay. Next statement. X dissolves in dilatory to form an orange color solution. Orange color solution. See? Dil H2SO4. Dil H2SO4. What will happen? Lead sulfate and this thing. Lead sulfate and this thing. No? Barium sulfate and this thing. That is what happens when salts are reacting. S-dog salts. S-dog guys reactions, right? Okay, they are not looking for the precipitate only. Right now. Right? So what will happen? So chromates with Dil H plus. You know the chromates are yellowish colored. Chromates are yellowish colored. When it is added to a Dil H plus, what will happen? What will happen? Yes. What is the knowledge there? This is the knowledge, right? You know that chromates and dichromates are with some kind of a equilibrium. Some kind of equilibrium, right? So the two oxygens of chromium, right? What will happen? Yeah, right? Chromates and dichromates. So Cr2O7 2 minus and CrO4 2 minus. These guys are with some equilibrium. Right? Okay. So, like it as like this. Sorry. This guy is orange in color. This guy is yellow in color. If you add some, right? If you add some H plus to the dichromates, Dil acids, it will convert to. Sorry, if you add some H plus to the chromate, it will convert to dichromate. If you add some OH minus to dichromate, it will convert to the chromate. Chromate is the oxygen which is stable in basic mediums. Dichromate is the oxygen which is stable in acidic mediums. Right? We had discussed this relationship last day with the chromium, the plus 6 oxygen state. Chromium's plus 6 oxygen state, 2 oxygens. The chromates will be converted to dichromates by adding H pluses, providing an acidic medium. Dichromates will convert to chromates when you are to provide some basic medium. That is what happens here. As acidic medium is applied, right? Dichromate will form. So just lead nitrate and barium nitrate as colorless solutions. Colorless solutions, and some dichromate, right? Orange. Nitric is used, right? Okay. Then, when H2SOs bubble through this solution, its color turned to green. right? H2S is bubbled to this solution. Color turn to green. Yes, this is your solution. Right? With H2S, what happens? Right? With H2S gas, chromates will reduce to CR3 plus. Chromates will reduce to CR3 plus, while H2S oxidizes to sulfur. Right? This is green solution. With this one as well, which H2S gas, this will convert to CR3 plus, reduce to CR3 plus, which is a green color solution. So still both stands. To this solution, its color turns to green. The solution gave green color to Bunsen flame. Solution gave green color to Bunsen flame. So in this solution, not only this, but this also appears. This also appears. So to the Bunsen flame, these are considered the solution with the cations, right? So to the Bunsen flame, flame test, this will give you a apple green color. Apple green color. But to the flame test here, you are not observing a characteristic color. No characteristic color. Right? So they are saying a green color is observed. So this is out. No characteristic color there. So your answer is barium chromate. Right? No? Answer is barium chromate. So answer is answer number 4. Clear, no? Just do the work. So here what happens is actually when dichromate reduces to CR3 plus, H2S oxidizes to sulfur, right? Here as when dichromate reduces to CR3 plus, H2S oxidizes to sulfur. Right? So sulfur products there. Right. Let's move to the question number 5. These are very important. Huh? Again and again, these things will be questioned, right? The precipitation table. All of these things are there in the precipitation table, right? The note number, which is the note number? Note number, I think it's 5, no? Note number 5, yeah. Note number 5 of the analytical institute, right? Precipitation table. There you have these all these points, right? Go to that, right? Okay. Let's come up with the next question. Right. Question number 5. See. First of all, let's write the choices there. Right. HgSO3, no? Then bismuth sulfide. cobalt sulfide. Right, fourth one, FeS. Fifth choice is nickel sulfide. See what they are see. When the inorganic compound P was heated with concrete Cl, a gas Q and a solution R was given with concrete Cl. Okay, right. Let's go to with that. With concrete Cl. Gases releases that is right. SO32 minus will release the SO2 gas, which is colorless, and this one will release the H2S gas, which is colorless. This one release the SO2 gas, colorless. Again H2S gas, colorless, and this one will release the H2S gas again. What they are saying? The concrete Cl, gas Q and solution R was given. This is Q and solution R was given. Solution? What is the solution then? See the solution? All are releasing gases, huh? We can't eliminate anything out from those, right? Solution. What is solution? So gas will be given by these two guys, combination of these two guys, H plus and SO2 minus. Solution will be given by the combination of the other two. So Hg2 plus is there with Cl minus. Hg2 plus and Cl minus. Huh? Cl2 there, right? And bismuth chloride, cobalt chloride, Fe, right? Cl2, right? The other one is nickel chloride. All are solutions, huh? No worries, no? No one will precipitate, no? Then Q decolors the filter paper with acidic KMNO4. Right? Q decolors the filter paper with acidic KMNO4. Right? So, what is the reaction there? So, with acidic KMNO4, see? What these gases will do? So, SO2 with MnO4 minus, SO2 oxidizes to SO42 minus, while MnO4 minus reduces to Mn2 plus. The solution will decolorize, right? With H2S as well, the same thing happens. With MnO4 minus, colloidal sulfur will form plus Mn2 plus. Right? These solutions are purple in color. And those will convert to colorless solutions. Decolorize in the acidic KMNO4. Both the gases do so. Both the gases do so. Right? Okay. Key decolorize a filter paper with acidic cheminophore decolorizer. Yes, the filter paper with acidic cheminophore is purple in color. It will decolorize. And R produced a greenish precipitate when treated with aqueous ammonia. With aqueous ammonia, see these guys with aqueous ammonia. Aqueous ammonia is capable of providing OH minus ions to the medium, right? Ammonia is kind of a base. Ammonia is kind of a base. So aqueous ammonia is capable of providing OH minus ions to the medium, as ammonia is kind of a base. Base means increase in the OH minus concentration of the solution, right? So with aqueous ammonia, aqueous ammonia is capable of providing OH minus ions to the solution, right? That means you can precipitate the hydroxides if the hydroxides are to be precipitated there. So we know when it comes to hydroxide precipitation pattern, right? So when it comes to hydroxide precipitation pattern, who are capable of precipitating hydroxides? Who are capable of precipitating hydroxides? If you think of Mn plus aqueous, right? When you are to provide OH minus to the solution, you come with MOH in precipitate. Here, Mn plus represents not beryllium 2 plus, magnesium 2 plus from this block, and all P and D block metal cations. All the P and D block metal cations are capable of precipitating hydroxides. This is what we have learned from precipitation table. This OH minus can be provided even by ammonia. Anything which make the medium basic. Right? Okay. So this is D block stuff, right? So mercury hydroxide will produce, and we had discussed about this thing, as this is unstable, it is kind of a inert metal hydroxide. No? Inert metal hydroxides are unstable. No? Will convert to mercury oxide. This is whitish and this is yellowish. And here we come up with bismuth hydroxide, cobalt hydroxide, FeOH2, nickel hydroxide. Right? So P block species are not with colors, but normally D block guys are with colors. P block species are not with colors, but normally D block guys are with colors other than the D10 confusion, right? So this is white. Right? PPDs are. Cobalt hydroxides, what is the color? Pink. Normally hydroxides will follow the colors of aqueous solutions. It's green. This is also green. Hydroxides will follow the colors of aqueous solution. Fe2 plus is green. Fe3 plus is yellowish brown. But Fe2 plus here. Right? So they are saying what? R produces a greenish precipitate. R produces a greenish precipitate. So greenish precipitate, so that we can get rid of the other guys. This is out, white PPDs. This is out, pink PPD. So just greenish precipitates, right? Green color things. Right. Then the precipitate formed above turn to brown when exposed to air. When exposed to air, turn to brown. So what will happen? Fe2 plus will air oxidize. Will air oxidize to Fe3 plus. So if is stable form is Fe3 plus. So normally Fe2 plus things will air oxidize to red brown. Red brown BBT. So no such kind of air oxidation here. No such kind of air oxidation here. This air oxidation can be speed up with the use of H2O2. We had discussed last day. Fe2 plus aqueous solutions as well Fe hydroxide precipitate will air oxidize to Fe3 compounds. That air oxidation can be speed up by using H2O2. Slowly air oxidation occurs. If you need to do it quickly, you can use H2O2. Right? So that has been discussed last day. Let's go to the Fe stable, ion stable, right? There you have this thing. So Fe is going to be your answer. No air oxidation with the nickel. Because nickel, you don't have more high oxidation states than the 2 plus. With the nickel, only 0 and plus 2 oxidation states are available. No greater oxidation state than the 2 plus for air oxidation. Right? No air oxidations occur with nickel and copper. These air oxidation things can be seen with manganese, iron and cobalt. Where some greater high oxidation states are available than the plus 2. Right? Okay. So the answer is iron. So no such kind of air oxidation with nickel. That is out. Right? So answer is going to be answer number 4. See how we had approached the answer. Let's complete this stuff now. So when it comes to hydroxide precipitates, in S block only the beryllium and magnesium will precipitate as hydroxides, but with the P and D block metal cations, all of those will precipitate as hydroxides. And to precipitate these hydroxides, this OH minus can be provided by a strong acid like NaOH, KOH, BaOH2, or you can use weak bases like ammonia. Sometimes the sodium carbonate stuff also can be used, right? Weak bases also capable of providing OH minus ions to the medium, that will also capable of providing the precipitate there. Right now, let's move towards the question number 6. Right. Question number 6. So let's come up with the choices first of all. First choice, copper sulfite, then nickel carbonate, third thing nickel nitride, no? Then fourth one nickel sulfide, fifth is copper carbonate, right now. Yes, let's see what they are saying. When DIL was added to inorganic salt Q, a gas and a colored solution was observed. Okay, so what you are adding is DIL. DIL. See what will happen? With the copper sulfide, this is how the gas is produced, no? H plus connects with the anion, this is how the gas is produced. And the metal with the Cl minus will form the solution or the salt, right? It could be appear as a salt or a precipitate, right? Okay, the gas release with the H plus SO3 2 minus will release the SO2 gas, colorless, right? And the copper chloride is a solution. Cu plus 2 here. What is the color here? What is the color here? Copper 2 plus aqueous solutions. Copper 2 plus aqueous solutions are light blue in color. Light blue in color. They are looking for which kind of solution? Colored solution, no? So we have to leave that thing. Gas and a colored solution, yes. That is okay. This one will release the CO3 2 minus with the DLH plus, release the CO2 gas, colorless gas, with nickel 2 plus connecting with Cl minus, nickel chloride, aqueous solution. What is the color here? So Cl minus ions won't have a color, but the nickel 2 plus ions come up with green color. Nickel 2 plus aqueous ions are green colored, right? The color of aqueous solutions are due to the D block involvement, nickel 2 plus ions there, right? This one also forms some colored gas, NO2 minus with H plus will form some colored gas, plus again nickel chloride. Nickel chloride is not kind of a precipitate, right? It is not precipitating chloride, right? Only 4 cations are capable of precipitating the chlorides solution. No? So color of the aqueous solution again due to the D block cation. So here as well, SO2 gas will release with the when reacting H plus with SO2 minus, right? And that is colorless, and your nickel chloride will produce green color. Here as well, CO2 colorless gas will release with some the copper chloride aqueous solution. This again comes up with the color of CO2 plus ions, right? The CO2 plus aqueous ions are light blue. Okay, so all the guys should appear there, no? Right? It will salt Q. Gas and a colored solution was observed. Gas and a colored solution was observed, right? Okay, all things are appearing there. The gas won't change the color of an acidic chemical solution. Gas won't change the color of an acidic chemical solution. So that is the CO2 gas. That is the CO2 gas. Won't change the color of acidic chemical solution. That is the CO2 gas. So out of those 5 gases, right, only CO2 is not changing the color of chemical solution. Only CO2 is not changing the color of those oxidizing agents. Right? If you need the theory there, right? when considering gases release its DLH plus, right? The CO2 gas is the only one won't react with oxidizing agents. But other gases, the H2S, SO2 as well as NO2 will react with oxidizing agents as those are not with their highest oxidation states. As those are not with their highest oxidation states. The CO2 guy is with its highest oxidation state. Won't get oxidized. Can't get oxidized actually. If you are with your highest oxidation state, you can't get oxidized, further oxidized. You can't get further oxidized. But when you are not with your highest oxidation state, you can get oxidized, right? So these guys are not with their highest oxidation state, right? -2 plus 4 are not the highest oxidation of sulfur. The highest oxidation of sulfur is +6. And for the nitrogen, +4 is not the highest oxidation, +5 is the highest oxidation, right? With oxidizing agents, these converts to these. They are oxidizing agents reacts and change their color. Here OA could be H plus KMnO4, OH plus dichromate, right? KMnO4 basically converts to Mn2 plus, dichromate convert to Cr3 plus, change their colors, or this can be conc HNO3. It will convert to NO2 gas. Right? This is not there. So CO2 is the only one which won't react with oxidizing agents, right? As it is its greater oxidation state. So others are out. They are saying the gas won't change the color of acidic KMnO solution. So these will change the color of acidic KMnO solutions. So these are out. These are out. So the answer could be nickel from nickel carbonate. Oh, sorry, this is not the case. This is out. Sorry, copper carbonate. Right now. Okay. See, when excess of ammonia, right, when excess of ammonia was added to the colored solution, so the colored solution is this. So you are adding excess of ammonia to this. So what will happen now? If you are a D7 D10 cation, excess ammonia will convert you to the amine complex. If you are not a D7 D10 cation, then you will form the hydroxide precipitate if you are capable of forming those precipitates. Right? If you are a D7 D10 cation, your hydroxide precipitate will dissolve and form the amine complex. But if you are not a D7 D10 cation, and if you are capable of producing hydroxide precipitates, you will remain as the hydroxide precipitate. This is what happens with the excess ammonia, right? So these guys are D7 D10 cations. Nickel coming up with D8 configuration, copper coming up with D9, S1 D10, right? So D7 D10 cations. So this is coming up with as D8 configuration. This is coming up with D10 actually, no? You can say D9 configuration as copper 2 plus cation. These ingredient cations so produce amine complexes. Amine complexes. Nickel amine. So nickel amine comes up with 6 amine ligands. What is the color there? Blue color. Copper amine coming up with 4 amine ligands. Or is 2 plus. What is the color there? Dark blue. Right? What they are saying, see. When excess of ammonia was added to colored solution, it turns to dark blue. It turns to dark blue. Most probably the copper thing. Most probably copper thing. Don't confirm with that thing, right? That observation, because both are blue, no? Just dark and just blue, no? Don't confirm just only from that thing. Let's go to the other statement as well. Most probably this could be the copper, but don't confirm by that thing. Just blue and dark blue, no? Right? Okay. Then when H2S was bubbled through another portion of colored solution, a black PPD was observed. Right? Bubbled through another portion of the colored solution, black PPD was observed. So remember, these are some solutions in acidic medium. So these are obtained after adding dill acid. These are obtained after adding a dill acid. So these are actually solutions in acidic medium. These are actually solutions in acidic medium. These are acidic solutions, right? Because they are those obtained after adding dill H plus. After adding dill H plus, you obtain these PBDs, sorry, these solutions. So in acidic mediums, you have it these compounds, right? Okay. To that you are adding H2S. To that you are adding H2S. So it is kind of acidic medium H2S. It's kind of acidic medium H2S. See? Added to acidic solution. These are acidic solutions, right? These are obtained by adding HCl, which is an acid, right? So in acidic medium, the copper will precipitate as copper sulfide. Black PPT, but not the nickel, See, nickel comes under group analysis group 4. Nickel comes under group analysis group 4. Copper comes under group analysis group 2. In acidic medium H2S, group analysis group 2 cations will get precipitated, not the group 4 cations. They will remain in the solution. That is why they are capable of precipitating at the group 4, as they were remained with the group group 2 analysis at the solution. Right? So copper is kind of cation at the group 2 analysis. So in acidic medium H2S, it will get precipitated. But nickel is kind of cation coming up with the group 4 analysis in group analysis, right? So it won't get precipitated with acidic medium H2S, right? So what they are saying is, when H2S was bubbled to another portion of color solution, a black PPD was observed. Black PPD observed. So that is copper, not the nickel. You don't have a precipitate there with the nickel, as it is group analysis group 4. Right? So your answer is copper carbonate. Answer is answer number 5. Right now? So just do the working. Right, let's move to the question number 7. Question number 7. මුලින්ම පිළියාගන්න බෑනේ අපි කට්ටිය අවදි කියලා ඉන්නේ. Number 1, barium iodide. Number 2, copper iodide. Number 3, CuI2. Number 4, NaBr2. Number 5, copper nitrate. So do you have a question there? Yes, please. Right. Hari. Organic tube එක අහලා තියෙන right. හරි ස්කූල් සමහර ස්කූල් වල ඕගනික් කරනවා. ඉතින් ඕගනික් ටියුට් එකක් අහලා තියෙනවා. right. හරි මම මේක ළම මේ මම ඔයාලට ඉගෙන කියන්නම් කතාව. අතන ඕගනික් ටියුට්ස් ඉවරයි. හරිද? මම ඔයාලට වෙනම ඒ ටියුට් එකේ soft copy ගෙවන්න. එතකොට ඒක ඔයා එතනින් ගන්න කියලා තමයි කියන්න වෙන්නේ. Last day I tried to give you a tute but the printed copies are done. ඉවරයි. හරි. right මම ඔයාලට කතා කරන්නම් හිට. හරි ඒක. හරි. next up. Number 7. right. මොකද question එකේ ඉන්නේ. right let's go to the question. right. see. A water soluble inorganic compound. water soluble. A soluble නැති කට්ටියම අයින් කරමු. හරි. හැම point එකම වැදගත්. each and every point is important as we are following the elimination technique. Each point is important. A water soluble compound, they are saying. If it is not water soluble, just emit those. Make out. This is out. This is out. Right? Alright. The reason. X minus precipitates. Earlier also I had written this thing. Only 4 precipitates are only 4 cations are capable of precipitating X minus halogens. Ag plus, Pb2 plus, Hg plus, and then Cu plus. This is plus 1, right? Not the plus 2. Copper plus 2 is not capable of producing the precipitate of halides, right? But copper plus 1. Agx, Pbx2, Hgx or Hg2x2, Cux, right? So you see, Cux is kind of a precipitate. So they are saying that water soluble inorganic compound. This is water insoluble. This is insoluble. This is insoluble. Water insoluble. It's a PBD. It is out. Right? No need of copper iodide now. No need of concerning about that thing, right? Okay. A water soluble inorganic compound gave a colored gas and a blue solution with conc H2SO4. Colored gas, blue solution with conc H2SO4. Conc H2SO4. So I minus will produce the I2 gas, which is purple, and barium sulfate. These two will give the I2 gas, and barium 2 plus with sulfate will give barium sulfate. It's a PBD. white PPT. They are saying colored gas and a colored blue solution. It is out. Not giving you a blue solution. Not giving you a blue solution. White PPT. So here, I minus will produce I2 gas with conc sulfuric, purple colored gas, and copper connecting with sulfate. Copper connecting with sulfate, copper sulfate. Blue solution. Blue solution, yes. That can stand, right? So here, Br minus with H plus, conc H plus will give you the Br2 colored gas, red brown. Na plus with sulfate, Na2SO4. It's a colorless. So if D block is not involved in the solution, if the D block is not involved in the solution, those are colorless. This copper sulfate solution is colored because of the copper 2 plus ions, not because of sulfate ions, but with the as the copper 2 plus ions are appearing there, that is the reason for the blue color, light blue. So this is out. Colorless solution. We are looking for blue color solution. With this one, we will produce NO3 minus, we will produce the NO2 gas, which is red brown, and copper sulfate, copper 2 plus consists the sulfate to form the copper sulfate, again a colored solution, light blue. Right now? So these two stand while others we reject those, right? Okay. Then the colored gas, no, it's not the gas, right? It's gas, right? The colored gas obtained was crystallized naturally to form black crystals. That is important. No? That is important. So this is the colored gas. Now that is about I2, Lama. That is about I2. This thing crystallize at room temperature. Crystallize at room temperature. You know, the I2 is a solid at room temperature. I2 is a solid at room temperature, Lama. You know the stuff, right? When considering halogens, F2, Cl2 are gases at room conditions. Br2 appears as a liquid in room conditions. That means 25 is 180. Right? I2 appears as a solid. So the I2 gas produced like this will crystallize when cooling. When that is released to the atmosphere, it get cooled, no? Right? So that it will crystallize. It will solidify. So I2 solid is kind of a very dark, very dark purple color, coming up with a very dark purple color, which will appear as a black residue. Very dark purple, which will appear as a black residue. Such dark, right? So crystallize at room temperature to give you a black residue, which is the I2 solid. So answer is CuI2, not this one. This one won't crystallize, right? Okay. Right? So the colored gas obtained was crystallized naturally, without doing anything. Naturally, it will crystallize to form black crystals. Yes. So the answer is copper iodide then. The solution turned deep blue upon addition of excess ammonium chloride in the presence of ammonium hydroxide. So let's discuss about that thing as well. So it comes this one. This coming up as a D9 solution, D9 cation there. So if you are to come up with some ammonia NH4OH, what will happen? D9 things. D9 things will form amine complexes. Copper amine complex. That will happen with this thing as well. But the answer will be taken from here, not from here, right? Because this thing also gives you the same solution, right? Copper comes up with 4 amine ligands, 2 plus. This is dark blue. Right? So it tallies with the observation. So answer number 3, copper iodide. Right now? Okay, just do the working. Remember that I2 is a solid at room conditions. I2 is a solid at room conditions. Normally, when you are adding concave H2SO4, you heat the stuff. Concave H2SO4 and heating will be done normally to release these colored gases. So when it released to the atmosphere, it just cooled, right, and come up as a black colored residue ultimately. It is very important here, right? When it comes to X minus precipitates, copper plus appears here. Copper 2 plus won't precipitate the halides. Copper plus only. In this case also, mercury plus precipitates the halides, not the mercury 2 plus, the plus ones. Ag plus, Pb2 plus. Right, no? Right. Let's come up with the question number 9 there. Sorry, question number 8, no? Question number 8. First, let's come up with the choices there. NO2 thrice, Cr2SO3 thrice, then Cr2 carbonate thrice. 14 is copper sulfide. 16 is copper nitride, right? See, copper nitride. Right, okay, see. An inorganic compound A gave a colored solution and a colorless gas with dill HCl. Okay, with dill HCl. No? What will happen? So with dill HCl, this releases NO2 gas. NO2 minus ions will release the NO2 gas. This red brown. And these two connects to give you the gas, and these two connects to give you the solution. Fe3 plus here, Fe3 plus here, Fe3 plus here connects to the Cl minus 2, copper in the FeCl3. What is the color here? The color of the FeCl3 solution is due to color of Fe3 plus ions, right? Cl minus ions won't have colors. The colorful aqueous ions coming from the D block cations, right? D block species, right? So Fe3 plus the color is, Fe3 plus aqueous solutions are Yellow brown. This one. So we are looking for colored solution and colorless gas. Colored solution and colorless gas. We are looking for colorless gas. So that this is out. This is providing you a colored gas. Colored gas. So it is out. We are looking for colorless gas. Looking for colorless gas. That is out. With this one, so these two connects to give you SO2 gas. These two connects to give you chromium chloride. SO2 is kind of a colorless gas. And these two connects to H2SO3, that means SO2 gas. So H2SO3 that gives you SO2 gas, while the Cl minus connects to the Cr3 plus to give you CrCl3. Color is due to Cr3 plus aqueous ions. Acidic Cr3 plus aqueous ions in acidic medium. So Cr3 plus aqueous in acidic medium is green. So that stands, no? Colorless gas is a colored solution. Colored solution, colorless gas. It is okay. Next one. Here CO2 gas will liberate with the carbonate ions, which is colorless, and CrCl3, like in the earlier case, green in color. It stands also. This one, SO2 gas will liberate with H plus and SO32 minus, and copper chloride. With copper chloride. Color of copper chloride is due to the copper 2 plus ions, that is light blue. Deep blue cations give the colors to the aqueous solutions. Right, it also stands. This one, this thing will produce the NO2 gas, NO2 minus with the H plus, NO2 gas and copper chloride. Is red brown and copper chloride. So that is out, right? Red brown gas, that is out. We are looking for colorless gas. We are looking for colorless gas. Red brown out. We are looking for colorless gas. Right? Because of this, two guys out. So it is said that an aqueous solution of this gas so obtained. The aqueous solution of this gas so obtained. That means these gas so obtained gave a precipitate with H2S gas. Gave a precipitate with H2S gas. Okay, let's see what will happen there. Right? So SO2 with H2S, and the other one is CO2 with H2S. See what will happen? Lama SO2 with H2S coming up with some special reaction. Lama, this new thing to you. This is a new thing to you. This sulfur coming up with plus 4 oxygen state. This sulfur coming up with minus 2 oxygen state. Right? If something like this happens, we have two compounds coming up with two different oxygen states of the same element. If two compounds are coming up with two different oxygen states of the same element, then one will oxidize and other will reduce to a common oxygen state in between. To the common oxygen state in between. So here, the common oxygen state in between the plus 4 and the minus 2 of sulfur is 0. So this one will reduce to 0 sulfur. This one will oxidize to 0 sulfur. Right? That is the reaction. That is the reaction, right? So such a reaction will occur. These are kind of a common nature, right? with P block species, right? This is the first time you learn this one, right? Okay, this is how the things are to be balanced, right? So these kind of stuff are common with P block stuff, right? So basically you can see these kind of things when I minus reacting with IO3 minus. This is minus 1 oxidation state. This is plus 5 oxidation state. Both comes to the most stable oxidation state in between to the I2 0. So if you are to react some sulfur with conc H2SO4, 0 plus 6, the oxidation state in between is plus 4. Towards that, one will oxidize and other will reduce. Water will be needed. Water will be needed to balance this up, right? Balance the oxidations, water is needed, no? Right? Such kind of things are very common in P block chemistry. This is the first time you are hearing this stuff, right? As we haven't done the P block yet, right? Okay. So with this one, no such reaction, na? Both the acids and no such reactions. No such reaction there, right? Okay. Okay. Both acidic gases, no reaction there. Right. So this is the stuff we are using. Right, to differentiate these two gases. Right? Okay. So SO2 will provide colloidal sulfur if it is to bubble through a H2S solution. If it is to bubble through a H2S solution, it will produce the colloidal sulfur, not the CO2 gas. So what they are saying is an aqueous solution of this gas so obtained gave a precipitate with H2S. So what they are mentioning as precipitate is this colloidal sulfur. This colloidal sulfur. White colloidal unclear solution. Sometimes this colloidal sulfur formation can be referred to as a precipitate even, right? So that is a turbid situation, right? So that is what they are referring there. So that chromium is out. So that the chromium thing is out because such observation is not available with CO2 gas, right? Okay. These are some few more examples for this trend. Right. So now we are with two guys. See what they are saying with those guys. The colored solution reacted with excess ammonia to produce a colored precipitate. So we have two solutions here. This is a colored solution, green color solution, and here as well, light blue solution. So you are adding excess ammonia. This is kind of a D7 to D10. This is kind of D7 to D10. This is D9. D9. So that it will produce the amine complex. It will produce the amine complex. Copper amine with excess ammonia. It's a colored solution. What is the color? Dark blue. What happens with this? This is not going to be this is not a decent D10 thing. This is not a decent D10 thing. So that it will produce the hydroxide precipitate. Only if you are a decent D10 cation, you are capable of producing the amine complexes, which are solutions. But if you are not a decent D10 cation appearing in the D block, you will produce the hydroxide precipitate. Chromium hydroxide. Chromium hydroxide. Which is a PPT. What is the color? It is chromium hydroxide is blue-green in color. So only if you are a decent D10, you will come up with a solution in the form of amine complex. if you are a D block cation. All the other D block cations other than decent-butane will come up as hydroxyl precipitate with excess ammonia. So ammonia is capable of providing the OH minus ions to the solution as well. So that they are saying produce the colored precipitate. Colored precipitate. Produce the colored precipitate. Colored precipitate is produced. So that is not the decent butane. That is not the decent butane. That is what they are saying. So this is out. Produce the colored precipitate. Colored precipitate. That is what they are looking. Not this one. Not the solution. They are looking for the colored precipitate. So it is not the decent butane guy. The other one. So answer is chromium sulfide. Answer is chromium sulfide. The answer number 2. Answer number 2. Let's go to the review. Right now, let's discuss the 9th one. Right. Let's do the 9th one quickly. Question number 9. See, first let's come up with the choices there. Nickel sulfate, chromium sulfate, manganese nitrate, right now. So we have 2 here. No? Then K4, FeCe and 6. So it should be like this now, right? Just do that correction. It is K4, FeCe and 6, right? Potassium ferrocyanide. Potassium ferrocyanide, right? FeSO4. Right. Let's come up with the answers here. Right. An aqueous solution of certain inorganic compound Z was allowed to react with NH4OH and NH4SCN for several minutes. Okay. So NH4OH, NH4SCN. So those are normally used to identify the iron containing species. SCN minus is kind of a characteristic reagent to identify the Fe3 plus ions. Right? That is the theory there. No? So what is the theory there? So we have some theory there. Right? So in Fe chemistry, this is what we have learned. We could come up with Fe solid. Del H plus will convert it to Fe 2 plus aqueous. Right? Give me some OH minus, will convert it to FeOH 3. H plus will FeOH 2, sorry, 2 plus chemistry, right? And air oxidation will convert this to Fe3 plus aqueous. And this is also air oxidizes to Fe3 plus hydroxide. Precipitate, right? And HCN minus ions can be used to identify the Fe3 plus ions. Right? It will form FeHCN, those complexes. Blood red things. That is the Fe chemistry, no? What we had discussed. Right? This is 0 oxygen state, plus 2 oxygen state, and plus 3 oxygen state. These are precipitates, huh? Right, see what they are saying. An aqueous solution of a certain ionic compound Z was allowed to react with ammonium hydroxide and SCN minus. So basically we are looking for ion chemistry, kind of ion chemistry. When the for several means, when this reaction mixture was acidified with Dil H2SO4, a deep red solution was obtained. Deep red solution. So they are looking for this, right? This is deep red solution, no? This stuff. Deep red. Right? Okay. So what they are saying? Definitely it should be something containing Fe. Definitely it should be something containing Fe. Right? So we can get rid of these things. Definitely something containing Fe. But here, as well as here, the plus 2 is appearing, not the plus 3. Not the plus 3. Plus 2 is appearing with the two Fe compounds given in answers. Right? So these are rejected. This is in minus is a characteristics. Reagent for iron. Compounds. Right? Okay. Right. So what they are saying? Right. So means when this reaction mixture was acidified with Dil H2SO4, a deep red solution obtained. See, ultimately somehow they had obtained this thing. Ultimately somehow they had to obtain this thing. Right? And after acidifying, see what will happen there? What has happened there to obtain this one? Right? It was like this, Lamai. If you have started this thing, right? Adding NH4OH will convert it to here. Adding NH4OH will convert it to here. NH4OH and NH4Cl is added, no? So adding NH4OH, no? Sorry, NH4OH, NH4HCl is added. Adding NH4OH will convert it this thing to here. If you do plus to here. But nothing will happen with this one, no? Here the Fe is inside the complex. But here the Fe is outside the complex. So with this Fe2 plus, when adding NH4OH, it will convert to here. Then they are saying allowed to react with NH4OH, NH4HCl for several minutes. So several minutes, that means some time is allowed for the air oxidation. Several minutes, that means some time were allowed for air oxidation. So that converted to that converted to FeOH3. And when adding dil H2SO4, what has happened is this. What has happened is this. When adding dil H2SO4, that so produced FeOH3 converts to Fe3 plus. Then as HCl ions were there in the solution, that has converted to blood-braid PBT. See, that is the reaction scheme ultimately led to the blood-braid compound. So answer is this. So I'll tell you what happened there. It is like this, no? So at the starting solution, right, you had Fe2 plus, right? Then what you have done? You have added NH4OH with NH4HCl. Then with the use of this NH4OH, right, this Fe2 plus, the Fe2 plus here, right? FeSO4 means this, right? This is FeSO4 solution, right? Fe2 plus here connect to FeOH2, and HCl minus are still there, as you had added some HCl minus ions as well. HCl minus ions are still there, these ions, right? And allowed some time. They had kept some time. So they are saying that for several minutes. After several minutes, this has air oxidized. FeOH2 has air oxidized to FeOH3. Air oxidation. Of Fe2 plus to Fe3 plus, FeOH2 to FeOH3. This thing, right? Still, your solution contains HCl minus ions, which we added from here. Then to this thing, you are adding what? You are adding sulfuric, dil sulfuric, dil H plus in the form of sulfuric. Not 11. Then FeOH3 converts to Fe3 plus with the addition of H plus. The H plus joins with the OH minus to form the water, then Fe3 plus remains in the solution. So now you have the Fe3 plus AQ in the solution with some HCl minus ions. So what will happen there? That will eventually convert to FeHCl complex. Blood-braid complex. Right now? That is how the things happen, right? So the answer is FeSO4. So you can't do so with this one, as this Fe2 plus is complex. Not free to react like this. Not free to react like this. It is inside the sphere, complexed, right? So free Fe2 plus can do this kind of a reaction scheme, right? So the answer is answer number 5. Let's complete the stuff quickly. This is Cn minus ions added from the beginning, where they are till the end. That is why when you are adding LH plus, when the FeO is taken to Fe3 plus, that blood braid precipitate was blood braid thing was formed. This is a theory, right? Behind this thing. This was a path they took. FeOH2 went to here, then they oxidized, then with the addition of LH plus went to here, then Cn minus is added, so went to here. Was there in the solution, right? Went to here. This is the path. So let's quickly move to the last question. Question number 10. Right. See. Question number 10. Let's come up with the choices first of all. Copper nitrate, cobalt nitrate, cadmium nitrate, nickel nitrate, nickel nitrate. See, right. First statement says an inorganic compound D reacted with dill H2SO4 to produce a colored solution in a brown gas. Dill H2SO4. See, dill H is added. So NO2 minus, right? NO2 minus, NO3 minus won't produce gases with dill H plus. NO3 minus, to produce gases with dill H plus, you need to have carbonate, sulfide, SO32 minus, S2O2 minus, or NO2 minus. So no gas liberation there. So it is out. This is again another NO2 minus, NO3 minus. So no gas released. Again NO, all the things are NO3 minus. So this is NO2 minus, sorry for that. Right? This is NO2 minus, right? Right. So with this one, NO2 minus with DLH plus, NO2 gas, red brown gas will liberate. And when gas is released from these two will form the solution. Cadmium sulfate. This is a colorless solution. Right? Colorless solution. Because sulfate ions won't come up with colors, but cadmium is another D10 cation. D10 cation. D10 cations are not with colors. Even though other D block cations are with colors, D10 configuration without colors. So this is again NO3 minus, no gas liberation. Out with this one NO2 minus, so you will reduce NO2 gas, red brown gas with nickel sulfate aqueous solution. So the color of nickel sulfate solution is due to the nickel 2 plus ions. It is a D block cation. That color is green color. So what they are saying is what? DH2 to produce a colored solution and a brown gas. Colored solution and brown gas. This is also out. Colored solution. Colored solution. This is out. Out. Cadmium sulfide is colorless. D10 cations are colorless in aqueous medium. Right? D10 cations are colorless in aqueous medium. Cadmium appears just below the zinc in the periodic table. Just below the zinc in the periodic table, cadmium appears. So it is a D10 cation without a color. So we have the answer. Nickel nitrate. Nickel nitrate is the answer. So your answer is answer number 5. We'll discuss further about the question, but the answer is there. Right. Then addition of excess ammonia to this solution gave a blue colored solution. So excess ammonia to this kind of D10, sorry, D10 cation, right? So nickel coming up as a D8 cation, 28th element nickel, D8 cation. So excess ammonia. Amine complex, nickel amine. Nickel comes up with 6, cobalt and nickel coming up with 6 amine ligands. Right, what is the color? Blue solution. Right? Blue color solution. Upon passing H2S gas through the initially obtained colored solution, it just form a black precipitate. So if you have to add some H2S here, remember now you are with acidic solution, right? Acid is added and form the solution. So this is acidic solution. So H2S added to an acidic solution. So in acidic solutions, nickel sulfide, nickel 2 plus cations won't precipitate as sulfides. As nickel is kind of group 4 cation. Group 4 cations in group analysis won't precipitate in acidic mediums. It needs some basic medium H2S to precipitate. So no precipitate from group 4 cations in acidic medium. Right? So it says that, right? Upon passing H2S gas through the initial obtained color solution, it does not form black PVD. Does not form black PVD. Yes, that is true. The compound D would be, yes. Compound D is nickel sulfide. Right? Compound D is nickel sulfide. I know. So that is the answer for the question number 10. This is the review, right? Just complete this stuff. Right. So with this one, we are ending up the session for today. We had done the first 10 MCQ questions appearing at the page 12 and 13 of your workbook. So with the next session, we'll discuss the rest of the MCQs. Right. So I'll leave the board like this to complete your notes. Right. So with this stuff, we are ending the session today. Right. Okay. Goodbye then, and good night. See you next week.